Okay, so this question tells us that infinitely many rectangles sit on the x-axis and can be inscribed under the curve y equals e to the power of negative x squared. So determine the coordinates of C such that rectangle ABCD has maximum area. So what we're going to do is first write down the coordinates of C. So C is in the first quadrant. So if you move x to the right and y up, you get the coordinates of C, which is expressed as x, y for this reason. However, we can also express y as e to the power of negative x squared. So C is actually x, comma, e to the power of negative x squared. So those are the coordinates of C, and we just have to find out what x value would work for this. Now, what we can do is write out the area of the rectangle. So A is basically the mirror of D. So considering that this curve is symmetrical, given you have an x squared in there, so any value of x will just be squared, and it'll become the same thing as its negative counterpart. So we can say that D is x0, so A, which is the reflection, is negative x0. Likewise, B is the negative version of C, so it would be negative x, comma, e to the power of negative x squared. What this means is that the height of the rectangle is e to the power of negative x squared, and the width is 2x. It's x minus x, which is 2x. Now, what we're going to do is just write out the area as 2x e to the power of negative x squared, and then differentiate. Because when we differentiate, we can set it to 0, which gives us a maximum or minimum value. And in this case, we are looking for the maximum. So let's differentiate. The first part is we're going to use product rule. So 2x differentiated is just 2. So 2 times the other thing without the normal function of the other one, which is e to the power of negative x squared, is 2e to the power of negative x squared. You add this to 2, which is, 2x, which is the first function, times the derivative of the second function, which is negative 2x times e to the power of negative x squared in this case, which gives us 2e to the power of negative x squared minus 4x squared e to the power of negative x squared. And if we factor, we get 2 times 1 minus 2x squared times e to the power of negative x squared. What we can do is set this to 0, and we can break it up into its parts. So 1 minus 2x squared could equal 0, or e to the power of negative x squared could equal 0. However, we know that e to the power of negative x squared will never be 0, because anything to the power of x or anything to the power of something with x in it can never be 0. So this is crossed out. Now we can make 1 minus 2x squared equal to 0 by making 2x squared equal to 1, x squared equal to half, and x is equal to 1 over root 2, plus minus 1 over root 2, which is equal to plus minus root 2 over 2 when we rationalize the denominator. However, we know that C is a positive value because it's in the first quadrant for its x value. So we're going to write this as just root 2 over 2. And now we have that, we can just substitute this into the y value. So y is equal to e to the power of negative root 2 over 2 squared, which is equal to e to the power of negative half, which is equal to 1 over root e, which is equal to root e over e. So therefore, C is equal to root 2 over 2, comma, root e over e. And that's our final answer.